Okay, in this video, we're going to look at the rational root theorem. So the rational root theorem gives you a quick way to start to determine where your zeros can be. And what you do is you look at the lead coefficient and the constant, and then you divide them out. So remember, our lead coefficient is with the highest exponent. The constant is the one that has no variables at the end. And you do the p, which is the constant term, divided by the q, which is the lead coefficient. Once you write out all those possibilities, then what you're going to have to do is use either synthetic division or polynomial division to figure out if it's actually a zero or not. You could also actually substitute in to see if the function actually equals zero at that point. But the idea of using the division is that it actually ends up giving you, if you get a zero, it gives you other possibilities and options for the factoring of the rest of your polynomial. So to start number 36, which is the example from your packet, this would be your p, -6. This would be your q, 2. And then what you're going to do is list all the factors of p and then work them with all the factors of q. And again, these all are plus or minus. So the factors of p are 6, 3, 2, and 1. Okay, those are all the numbers that go into 6. And then the factors of q are 2 and 1. And so when we do plus or minus 6, for example, then we have to do 6 over 2 and 6 over 1. So plus or minus 6 over 2, the 1 factor. So 1 and 2 are the factors here. Our factors are 6, 3, 2, and 1. So again, this gives us the option of plus or minus 3 and then plus or minus 6. When we do 3 as our p factor, again, we do 2 for the q part, and then we also do 1 for the q part. 3 over 1 is plus or minus 3, which we've already come to that conclusion, and then this one is plus or minus 3 halves. So again, these are all our possible zeros. Okay, so then we're going to do 2 as our p. So 2 over 2, that means we have plus or minus 1. And then 2 over 1, that gives us plus or minus 2 as our possible zeros. And then finally, when we do 1 as our factor of p, we have a half when we divide it by 2. And then we have 1, which 1 over 1, which we've already done. So this gives us all of our possible rational zeros. Now, if you go and look on your answer key, because again, this is multiple choice, this is going to help you out. You're going to be able to determine which choices are your options. So you can see right now, it kind of narrows it down to option A or B if you go and look on your answer key. Because here's the other part about this. This is what takes a really, really long time. Now, when it asks you to find all the zeros, you're going to have to start to substitute in and see which ones work and which ones don't work. Now, here's what I would do, which I think is the smart way to do this type of problem when you have something that's multiple choice. If you notice, both choices A and B have 2 as one of the zeros, okay? So at this point, you know that one of the zeros has to be 2. So if you're going to go ahead and see if that's the only zero or if there's multiple other zeros, again, you're using those multiple choice answers to help you out here. I don't prefer synthetic division, so I go ahead and write this as a factor. So x minus 2 is my factor. If my 0 is 2, my factor is x minus 2, because remember, I get the 0 from setting x minus 2 to equal 0, and then when I add 2 to both sides, I get x is 2. So if I have a 0 to get the factor, I put the negative or the opposite of the 0 and bring it onto the side with the x. So then I'm going to go ahead and divide this out. I'm going to pause the video and then just do the long division so that you don't have to watch me go through all that. So now, once you've done that, you end up with 2x squared plus 10x plus 3. It does have a remainder of 0, so again, we know that 2 is a 0. So that's one of the reasons why we know that 2 is a 0. And again, if we looked at those options, both of them had that. Now, to see if it has any other zeros, again, what you could do is take one of the answers from the answer key and then divide that out. Or because these are rational zeros, again, you could just see if this factors. So the other choices he gave you was -3 and -1/3. So if you could either set those, you could actually think of this as x plus 3 and then x plus a third. Actually, I think that could be it, but it's not going to be it because of this 2 having a factor here. So never mind on that fault. But what you could do is, like, for example, you could take out -3 and start to divide that out and see if that becomes a 0. Again, if you did that, you would make your factor x plus 3, and you would do long division or synthetic division, depending on how you wanted to do it, with the 2x squared plus 10x plus 3. I'm going to pause again. So if I go ahead and do the division there, it turns out I'm going to have a remainder. So that tells me that, again, I don't have a rational 0 at -3. And so the option is, or the answer here is option B, and your only rational 0 is 2. We can double check this on Desmos, just making sure that that works. I know you don't have this option on the actual test, but I just want to make sure that this is the right answer, and that's a nice, easy way to do it. Oh, we do have the 1/3 and the 3. Oh no, we do not. These are not rational zeros. Okay, this has zeros, but these aren't rational, meaning they're not going to be able to be written as a fraction. So it was correct. 2 was only the rational 0 in this particular one. So this is something that takes a long time, and so I really suggest that when you're doing it, you use the answer choices to help you narrow down what you need to do in this particular case.